everyone and welcome. So for today's video presentation, we're going to tackle about parity checking. So in this video, we will explore what parity checking is and why it is important and how it used to digital communication and digital storage system. First, let's begin with a brief overview of what parity checking entails. So, parity checking is a fundamental technique used in computing to detect errors in transmitted or stored data. It involves adding an additional bit, known as a parity bit, to the data sequence. This parity bit is calculated in a such way that the total number of bits with a value of 1, including the parity bit, is always maintained at either an even or odd number. Now, you might be wondering why is parity checking is important? Well, in digital communication and data storage systems, ensuring the accuracy and integrity of transmitted or stored data is paramount. Errors can occur due to various factors such as electrical noise, signal interference, or hardware malfunctions. Parity checking provides a simple yet effective method for detecting these errors, particularly single-bit errors, which are among the most common types of errors in digital systems. To better understand how parity checking works, let's consider a real-world example. So, imagine you're sending a binary sequence of data, perhaps representing a message or a file from one computer to another over a network. Before sending a data, a parity bit is calculated and appended to the sequence. This parity bit serves as a form of redundancy, allowing the receiving computer to verify the integrity of the transmitted data upon arrival. Now, let's demonstrate how parity checking is performed using a single example in Python. We'll walk through a code implementation of a parity checker, which can add a parity bit to a binary sequence, transmit it, and then verify its integrity upon reception. So we have here a diff functions called calculate parity. So it takes a binary sequence as an input and it calculates for the sequence. It counts the number of ones in the sequence using NumPy. If the number is even, it sets the parity bit to 0, otherwise it sets it to 1. So we also create another functions which is the add parity bit. So this function takes a binary sequence as an input, calculates the parity bit using the calculate parity, and append the parity bit to the end of the sequence using NumPy's function. Then it returns the sequence with the appended parity bit. So we also have here another functions called check parity. So these functions take a binary sequence with a parity bit as an input. It extracts the original bits, calculates the parity bit for the original sequence using the calculate parity, and compares the calculated parity with a parity bit in the sequence. So if they match, it returns true, indicating that the parity check passed. Otherwise, it returns false, indicating that the parity check is failed. I also include if-else statement that will prompt a message in the terminal if it is parity check is passed or parity check is failed. So let's run the program and see what will happen. So as you can see, the retrieved data is passed and it has original sequence and the sequence with parity bit.